Okay, good morning, everybody, and welcome to the Mimic Consumer Choice with Menu-Based Conjoint webinar, hosted by your friends at Sawtooth Software. My name is Megan Pites, and I am the Ingenuity Ambassador here at Sawtooth Software. And what that means is that I am responsible for keeping our current customers satisfied, as well as getting the word out about some of our products and services. So if you ever have any questions about Sawtooth Software or your specific licenses, feel free to reach out. Now, while I'm going to help moderate this webinar and answer some of those burning questions, it is the man that you are all familiar with and Sawtooth Software's president, Brian Orm, that will actually be leading the webinar. Brian has been with Sawtooth Software for 20 years, and he was instrumental in creating the menu-based software that we're going to show you today. He was able to collaborate with a number of key individuals along the way, and thus we were able to create the first, if not the only, commercial system that enables the analysis and simulations of this kind of work. So I know Brian is very passionate about this type of research, and he's really excited to share some of this information with you. But before I turn it over, I do want to discuss a couple of housekeeping items before we get started. In the dashboard on the right, you will see an area where you can type in questions. Feel free to use this throughout the entire presentation. We'll do our best to get through all of those questions at the end, and anything unanswered can definitely be followed up via email to either myself or Brian. We're also recording this webinar, and we'll send along a link with the PowerPoint slides and examples after. There will also be a survey that would really help us tailor our future webinar offerings to our suite holders like you. So please be sure to give us your feedback. So I am going to now make Brian a presenter and let him take away the rest of the presentation. Okay, Brian, you should have control.
Great. Welcome everyone to this webinar. It's great to meet with you electronically. It'd be better, of course, in person, but I'm really pleased to be here for the next hour to be able to talk to you about a new and exciting area of conjoint analysis, kind of the latest and greatest thing to happen over the last decade, and that is menu-based choice. Our agenda today is to compare first the differences between CBC and menu-based choice to give you a flavor for when you should be thinking about menu-based choice versus standard CBC. We're going to show some examples on the screen of layouts that might lead you to think about menu-based choice. We're going to, of course, introduce the MBC software that we've developed for doing this. And we're going to talk a little bit about designing and programming in MBC. This, of course, is just an introduction. So you're not going to know how to do everything, but it'll give you a good flavor for what you're going to be getting into if you decide to go this route. Finally, we're going to show a unique application that you might not think of immediately as menu-based choice, but was an interesting application that we showed at the last Sawtooth Software Conference this year. When you go to buy products in the real world, you'll find menus everywhere. For, of course, restaurants, that's the typical menu. But when you go to buy technology products online, such as a laptop, you're often configuring your product before you purchase it on a website. When you go to buy a new product, such as a vehicle, a new vehicle, you might get involved in some sort of menu-based exercise as you configure the vehicle with the options that you want before you purchase it. Of course, when you subscribe to mobile cable phone services, it often involves some sort of menu where you select the options that you want depending upon how much usage you want and whether you want the triple play or just two parts of the triple play, etc. Even situations like a physician treating a patient in pharmaceutical research could involve a menu. You could be treating a particular patient and you could think about giving this patient a single drug or a multiple drug therapy. So it's not just a single select, it's a single or multiple select type configuration problem for the physician. And of course, when you think about traditional CBC, it often just can't mimic this actual buying process. And the thing that I'm going to keep on going back to is that you want the conjoint analysis survey to act as closely as possible to what the real buying process feels like for the respondent. Because if you don't mimic it very closely, then you might not be tapping into the same mental processes that real buyers go through before they click the trigger and open their wallets. So in review, the CBC, which of course is used in the majority of conjoint studies today in the world, respondents make a single choice among a set of pre-designed available options. 3 or 4 or 5 options might appear on the screen, and you ask the respondent which of these would you prefer, or would you pick none of these. However, with menu-based choice, respondents are essentially empowered to make from 0 to multiple selections of options on the way to building their preferred choice. They are constructing a product that they want to buy rather than just having to react in a buy, no buy, go, no-go sense to things that you've pre-configured for them. So it really is a different process. As just a simple motivating example, let's take a look at this menu. Which of the following options would you buy? There's options A through E, and the respondent may select as many as he or she wishes. And as the respondent picks items, and this particular respondent has picked A, C, and E, the total price dynamically and in real time changes right there on the screen, showing how much of the options you currently picked. And then once you're happy with your configuration, you click the next button and move on. Here's just a little extension of that same idea. Here are the same options A through E as you saw before, but this time the respondent first picks a base model, and then on top of that base model decides to configure options. So we have a multi-select here, a mutually exclusive choice, 1 of 3 here, and a select all or select none choice of up to 5 options after you've picked one of the base models. And again, as you pick the base model and the options, the total price is shown on the screen before and the respondent configures it until they're happy.
Hey, Brian, can I interrupt you for a quick second?
Yes.
So we're getting a little bit, I think we're getting a little bit of feedback. Is there any way you could pick up your phone for these couple of slides and then use the speaker just when you're showing the MBC software example?
I'm sorry, I don't understand, Megan. Is everybody able to hear me properly?
Yeah, I think there's a couple issues with the sound. It's kind of breaking up a little bit, so I'm wondering if maybe you're not on speakerphone. That might help.
Oh, you mean pick up physically the phone?
Yeah, yeah.
Okay, let me try that.
Not ideal.
Regular phone rather than speaker. Okay, now I'm on regular phone. How does that sound, Megan?
That's a lot better. So maybe we can do that until you have to use both hands.
Okay, I'll see what I can do.
Thanks, Brian.
Okay, this next example involves what we call the traditional kind of Dell model. I think Dell invented this model on the internet of buying your computer. They show you options for each of the attributes with upgrade prices. For example, if you want to upgrade to the 4 GB RAM versus 1 GB RAM, you can click it, but it adds $150 to your price. And for each attribute, the respondent must pick at least one of the options, I guess mutually exclusive, only one of the options within each factor until the total price of their product is shown and they're happy with what they've configured. That's another menu-based choice example. Here's a little bit more complex one involving something like a restaurant. For example, you can have some bundles on the top. If you buy the bundle, you'll get the hamburger, the fries, and the drink together. And that total price represents a discount over buying the hamburger, the fries, and the drink a la carte. But the buyer, the respondent, can look at this menu and decide whether they want to pick one of the bundled options or construct what they want to do in terms of the a la carte. And this allows you to test different bundling options and bundling discounts to see how people will trade off between buying bundles versus buying a la carte items and how to maximize the spend and profit for the menu. And this is a study that we've fielded before and have used in our trainings. Now here's an example that's fine. This actually came from David Bakken, who presented this at the Sawtooth Software Conference probably a little bit more than 10 years ago. This presentation that David gave at the Sawtooth Software Conference was one of the first times that my eyes were open to some of the greater opportunities beyond just standard CBC for menu-based tasks. And for that, I really thank David for leading the way and showing us some new ideas. So this is David Bakken's example having to do with buying some medical devices, specifically buying scalpels, forceps, and sutures. So imagine that you are in charge at a hospital of purchasing scalpels, forceps, and sutures. And this particular menu, although it looks a little bit complicated, you can either buy the scalpels, forceps, and sutures separately, some of them from brand A and some of them from brand B, or if you decide to essentially buy the bundle of all three types of products together from one brand, you would be able to click here and get them for a 20% discount. And so this represents a sort of bundling versus a la carte decision for medical devices purchasing for hospitals. Now, the pharma example, like I mentioned earlier, is a doctor might be ready to prescribe medication. A person may come into the office, a male aged 45 to 55 with hypertension, and then given this particular patient characteristic, this profile, the doctor would then look at the particular drugs that were available to prescribe and choose to prescribe one or multiple select, choose multiple drugs to simultaneously treat this particular patient. What's really neat about this particular thing is it looks like a CBC in a lot of ways, but you've got this element on top, the element of experimentally designed element that the patient characteristics can change. So the patient characteristics change in a kind of a little mini conjoint experiment here, and then a CBC-looking multi-select experiment happens here all together, and essentially we get not only that the probability of picking the drugs is not only a function of the characteristics of the drugs, but also we get some betas, or we get some utilities estimated for how the characteristics of the patient are beta weights to drive the probabilities of drugs, particular drugs being prescribed. Now, MBC is really the next step in your progress as a discrete choice analyst. You'll see that menu-based choice really extends and expands your capabilities into some really interesting areas. And developing skills with the menu-based choice technique can give you a leg up in your business and also in your career, because it sets you aside. It sets you apart as being able to do some of the most complex work out there, that it really is upper echelon stuff. So the recent customer feedback survey that Sawtooth Software did this spring reported that about 3% of the projects that our customers are doing nowadays in conjoint involve MBC or MBC methodology. So it is very much the upper tier kind of really specific type of research that is really elite. It's only about 3% of projects that are being done right now, and it's very likely that it's going to be always less than 10% of the projects, because most projects probably can go with standard CBC type research, but some of them are definitely much more appropriate for menu-based choice, and it's starting to take off. Now, this stuff is relatively new, but I want to assure you that multiple stringent methodological tests have been presented at the Sawtooth Software and SCIM conferences presented by us at Sawtooth Software, but also a number of really good analysts out at GFK and also great people out at SCIM. Each of these studies has been quite rigorous, involving large sample sizes, holdout tasks, holdout predictions, including not only kind of marginal predictions of the average likelihood of picking things off the menu, but combinatorial choice predictions at the individual level, having to predict what individuals would do in terms of precisely what combination of options that they would pick. And the menu-based choice methodology has proven that it can be very accurate at predicting not only the holdout average sample choices, but individual level predictions for holdout respondents. So that's something I wanted to assure you of and tell you it's been a very fun thing to do over the last 6 or 8 years to be able to be involved in those methodological tests. When we first released the software I think about 4 years ago, we had a beta test process, and some of our beta testers were, for example, Chris Moore at GFK and Christian Nuremberg at GFK. And Chris said, Sawtooth Software's new menu-based choice software has unlocked a field of conjoint that was only previously available to elite conjoint users. What would have taken the analysts days, probably weeks in some cases, to set up the analysis and simulations can now be accomplished in a matter of hours. And the flexibility that the software offers regarding specifying different cross-effect models means that MBC can now become a mainstream conjoint technique. I was particularly impressed with the way Sawtooth Software has designed the software to allow for the multitude of ways that accompany MBC projects, and I look forward to using it in the future. So that was what Chris Moore said, and he delivered a very interesting talk at the Sawtooth Software Conference involving menuing for TGI Fridays. It was a case study that he has published. It's available for free up at Sawtooth Software's website. You can download the proceedings, and he talks about how he configured the menu for TGI Fridays. TGI Fridays implemented some of the menu changes that his team suggested, and then he showed some results in terms of what happened to the sales for that test restaurant that they enabled the suggestions for. One thing you'll see from Chris's comments is, and he alludes to this, is menu-based choice is a lot more complicated to analyze than CBC. It typically takes multiple times more effort and time and sophistication to do than regular CBC. If you try to follow these steps and do it kind of home cooking on your own using R or SPSS or SAS with Excel, and you can do all the steps yourself if you're sophisticated and know how to code the design matrices and do the analysis and take the betas into the simulator and build your own simulator. And I've done that process manually, and it truly does take days, and in some cases, Chris says weeks, and if it's complex enough. And using the software makes it very, very rapid compared to doing it manually. I'll state that because I've done it personally both ways. Christian Nuremberg is the second person that gave a quote on this page, and interestingly enough, Christian Nuremberg recently finished his PhD, and his thesis was on menu-based choice. So he spent 3 or 4 years in his doctoral thesis working on menu-based problems outside of Sawtooth Software's tools, and then he had an opportunity to use our tool. After using our tool, he said, Sawtooth Software's new MBC software is not only a very convenient and flexible tool for menu-based modeling, it can be regarded as a multi-purpose tool for all types of advanced discrete choice modeling. So that gives you an introduction and some ideas from what some of the people who have used the software outside of our company have said about it. What the MBC software does for you is it takes an analysis and simulation building process that can take sophisticated modelers more than a week if they do it manually, using R and SPSS and SAS and whatever LIMDEP, whatever sort of discrete choice modeling software they want to use. And what it does is it compresses the time and makes it a lot easier to do, which allows you to investigate many more models and model specifications along the way than you'd be able to do if you were doing it in a more manual process, which means you can build better end models for the client and get more predictive, more accurate simulators. The software and the documentation for MBC gives you suggested patterns and examples to follow, so you can learn how to do some pretty sophisticated discrete choice modeling projects. What's also neat about the software is it can create a default starting point Excel simulator with all the formulas and all the data, and it computes right there the shares of preference so that you can deliver a very nice Excel simulator by gussing it up a little bit and making a little bit prettier interface, customizing it with your own branding, etc., and deliver this Excel simulator to your clients. So that's something really neat that the MBC software can do that previous conjoint software from Sawtooth Software, you haven't seen our software being able to do that yet. So that's a neat little thing that we have implemented with the new menu-based choice software.
And we are going to
now,
Brian, we are going to implement that with the new SMRT in version 9, right?
It's not called SMRT inversion.
Sorry, yes.
SMRT, of course, is the old platform that's dying and going away. But the new market simulator that we're integrating within SSI Web is going to be able to create an Excel-based simulator as a starting point for you as well. So that's a neat thing that we are looking forward to.
Thanks.
So MBC Software can do quite a few things for you, but it doesn't do everything for you. Because there's so many possible ways that you can build menus. I showed just a few examples at the beginning of this presentation. The process of actually writing the questionnaire is something that you'll need to do still manually, and you will need to design the experiments, and nicely the experimental design for menu-based choice follows very closely to the principles and everything you've already learned about standard conjoint. So you can use standard CBC or Sawtooth Software's CVA software for traditional ratings-based conjoint designs, or any sort of third-party solution like Jump, etc. SAS got beautiful designers in both of those products as well to design your experiment. So you just use the typical principles you've already learned, and then you can use, for example, SSI Web's free format question type to construct and field these menu-based choice questionnaires. It's going to involve some custom JavaScripting that you'll need to do to fully implement this questionnaire, or if you've got another third-party platform that you prefer to program in for creating web-based surveys, and it has the sophistication to be able to build these kinds of menus and do some custom JavaScripting, feel free to use those as well. MBC Software doesn't do all the thinking for you. It's not as point and shoot as Sawtooth Software's MaxDiff and CBC by any stretch of the imagination. It takes a person who knows what they're doing, because you have to think about how you want to build the models and how you want to use the multivariate statistics to be able to use it properly. You can't just turn this over to a junior analyst like you can MaxDiff. This takes an individual who's had a lot of thinking and training in discrete choice modeling and building models for both logit and also hierarchical Bayesian models. But what MBC Software does is it handles all the really tricky data processing steps, especially the model specification. When you want to say, I want to use these main effects, I want to use these cross effects, I want to specify a linear model versus a log linear versus a part worth model. The software lets you, just with a point-and-click interface, toggle back and forth between a lot of model specifications so that you can investigate a lot of very different models that would take a lot of time to try to do manually if you were trying to code your design matrices each time you tried to do a slightly different model specification. It also handles and manages all the utility runs that you do, the logit runs, the hierarchical Bayesian run, manages them in a nice utility run manager, and lets you build the market simulator once you have created the model specification and settled on the utility runs that you want to use in your final simulator. So in so many ways, it saves you a great deal of time. Now, the key elements of menu-based choice studies are that respondents can select from multiple items on the menus. They can select one or multiple. You can restrict or not restrict the way that people can pick these. And respondents can, of course, pick from one to many in bundles on the menu or a la carte items on the menu. Price is often involved in menu-based studies, but price really doesn't have to be an element of a menu-based study. You can think of a lot of examples where price really wouldn't need to be done. The other thing that's neat about menus is you can test what happens when items become available on the menu or disappear from the menu, and that becomes availability effects that you estimate to see what happens to the other items on the menu when a new item comes on. So going back to the initial example I showed you, A through E, 5 options on the screen where we have a price attached to each option. And how would we design this? How would we think about this as we were starting out to design this particular study? It's really not that hard, and you've already thought about it before in your traditional conjoint work. It's typical to ask respondents to complete about 8 to 12 of these tasks. So we're going to create an experimental design that typically shows about 8 to 12 of these menu tasks per person. where the prices or the availability of the items can change and do change from task to task. And not surprisingly, we vary the prices independently using some sort of near orthogonal or orthogonal experiment so that the effect of each price change can be estimated separately and independently of the others. So all very typical. So when you think about this menu with 5 items on the screen with prices, each option, for example, we might think of the price of option A as having 3 possible prices, $12, $14, and $16. And similarly for all 5 items, we could think of a 3 to the 5th, a 3 by 3 by 3 by 3 by 3 experimental design. Or we could have had a 4 to the 5th if we wanted each option to have 4 price levels. So this is like a conditional pricing matrix that you might think about for regular CBC, but we're going to think about the experimental design as if it is 5 attributes, each with 3 levels. And then you're just going to design the experiment like you regularly would do for a Paul Green rating style 1970s traditional conjoint analysis study, 5 attributes, each with 3 levels. So if we have this 3 to the 5th design, then each card or profile, and again, think in terms of 1970s Paul Green card sort conjoint idea, each card really defines the prices that you're going to show on the entire menu. So one profile drives what the menu shows. And for the full factorial, there would be 243 possible price combinations in this particularly small design. And again, you don't have to think about doing a full factorial experiment. A fractional factorial experiment using experimental design software or catalogs can be used so that you only have to show a fraction of all the possible price combinations to your respondents, and particularly to any individual one respondent. So in terms of programming the study, after you've got your experimental design, and again you can use Sawtooth Software's CBC software or Sawtooth Software's CVA software to generate those experiments. In that example I just showed you, you just say, hey, there's 5 attributes, each with 3 levels, generate an experimental design. Once you've got that experimental design, SSI Web can tap dynamically into that experimental design using its free format questions. And we have special keywords in SSI script functions like the CBC design level text script function, which is documented in SSI Web, to be able to tap into what level text to show on the screen in this task to this respondent. And so you can dynamically tap into the designs and display dynamically onto the screen using HTML what needs to be shown. And you're typically going to add to that free format HTML question some JavaScript to be able to add up the prices for the selected items in real time, so that as the respondent checks the items, immediately the price changes. And our software for menu-based choice does not help you write or field the questionnaire per se. You do it within SSI Web or within another survey programming software of your choice. And we have some examples that we can share of MBC questionnaires that we've programmed within SSI Web. If you follow up with Megan, she can, and maybe she'll just do this automatically for all of you. We can zip up those .ssi files and send them out to you so that you can open them up in version 8 of SSI Web and be able to see how we've implemented the free format CBC questions, how we've implemented the JavaScript to be able to do 2 or 3 examples, so you can use those as starting points. For those of you who've used SSI Web before and who have used the free format question, you know that the free format question just kind of opens up with a blank HTML editing area and lets you specify the HTML to use, and then lets you add variables to the interface so that the SSI Web can manage your HTML and manage the variables that you're collecting, so that the data gets stored in the database and you can conduct the analysis. So you would do this if you're using SSI Web to program a menu-based study, and then you would export the data out of SSI Web to a CSV file, an Excel-compatible file. And luckily, the data layout for menu-based choice is really quite simple, and I'll show it to you in a little bit. But for example, this free format question with this HTML that I've programmed if you click the preview button, looks like this, and when you preview the questionnaire and when the respondent takes it. So the free format question renders all the HTML. Of course, the browser renders the HTML, shows it on the screen, and these prices dynamically each tap into the experimental design. Each one of these price points in the menu comes from a separate attribute that's in the CBC design file that's being stored behind the scenes in the SSI Web project, and each task dynamically taps into the price point that it should show for each task so that you get the experiment fielded and the prices vary independently, and this, after you've collected the data, allows you to estimate all the price effects on how these price changes will affect people picking the items on the menu. Now, I'm going to show you a simple example and show you the data file format, open up the MBC software, and show you how to do the analysis. Let's imagine, for fun, that we're all on a cruise in Hawaii, and the cruise ship pulls into Maui and docks there for 2 days. And while you're in Maui, you can pick from different cruise options to be these excursions that you can sign up for. You can choose to not do any of these excursions that are offered by the cruise line, or you can choose to do all of them. Each of them takes a half a day, so in a 2-day period you could actually experience all 4 of these. And for this we generated some pretend data. This is fictitious data and a fictitious example, but it'll allow us to be able to show you the software and show you how the analysis works. We're going to have 250 respondents, where each respondent completed 10 tasks. Each task looked like this. The respondent was asked, imagine you are on a cruise ship that docked in Maui for 2 days. The ship offers the following excursions for your enjoyment. Which, if any, would you choose? Select all that apply. And so in this particular task, the prices were this, but in another task, of course, the prices are going to change. In each task, the respondents asked what they would do, how many of these excursions they would sign up for if they had 2 days in Maui, and the prices were these. So that's the setup. But I'm going to show you how, after you collected this in SSI Web, you would export the data and do a little bit of massaging of the data to organize it into the proper format, and I'm going to just open it up in Excel. So I'm going to bounce over to a folder where I have this Hawaii data set formatted. I've exported it out of SSI Web, and then I've just formatted it within a CSV file in Excel. And it, depending on your data processing skills, it may take you a half an hour to an hour or two to format the data like this. It just depends on your skills. Once you've done it a few times, it's pretty quick. But it's a very simple data layout. We only have 9 columns here. The first column is the case ID. Each respondent completes 10 tasks. So we've formatted this as 1 task per row. So this respondent, case ID number 1, is formatted as 10 rows in this particular data file. Now, each row is a task. And so you can see that respondent number 1, for task number 1, saw certain prices, and I'm going to expand these columns just a little bit so you can read the labels. Each task involves 4 prices, because we have 4 variables: the Lahaina shopping trip price, the whale watching trip price, the surfing price, the snorkeling trip price, and these numbers between 1 and 4 indicate whether it was price level 1, price level 2, price level 3, or price level 4. So these are the independent variables for each task. What price level was shown on the menu? Then the last 4 variables for this particular respondent are the dependent variables. There's 4 dependent variables, whether they chose or not each of these particular options on the screen. I've formatted the data so that a 1 indicates true and a 2 indicates false on the screen. So again, if I just go back to showing you the menu, the respondent had 4 dependent variables, picking or not picking these 4 different shopping trips, and there are 4 different prices involved. So we can simply format that in Excel as 9 columns: the case ID, the independent variables, and the dependent variables. The independent variables and the dependent variables can occur in any order in this particular file, because when we open this file in the software, we're going to be able to specify which columns, which variables it reads in are the independent and the dependent variables. So here comes respondent number 2, and respondent number 3 follows, etc. So very, very simple data layout. Oops, that's going to come up later. Pay no attention to that yet. That's coming up. So now that I have set up my data for this Maui shopping trip, I'm going to open it up in the software. So we're going to go over, and I'm going to launch the menu-based choice software off of my start menu. And you're going to find that in a lot of ways it kind of looks a lot like CBC HB software. So it's kind of based on the same type of menuing, but more sophisticated than the CBC HB software. So if you're familiar with CBC HB, it kind of gives you a feel for what it's like to work within menu-based choice. To start out with, you get a project wizard that you can use to create a new project. And I am going to create a new project. I'm going to browse to a data file. So I know I've already created the data file with the proper format, and the documentation of this software shows you the format. And we'd be pleased to, if you haven't already downloaded the documentation for MBC, Megan would be happy to point you to the PDF file, which has the full documentation. And by the way, I would state that even if you don't plan to use this software to do your menu-based stuff, even if you plan to do it homebrew with R or SAS or whatever tools you want to use, reading the documentation will give you a lot of insights into the process of designing and analyzing and building simulators for menu-based choice experiments. So even if you don't plan to buy this software, the documentation is very, very helpful if you plan to do it homebrew. So here we go. I'm going to browse to the data file that I created. And notice I also have a labels file prepared. I'm not going to have enough time to talk to you about the labels file, but it's a simple way that you can just create in Excel a labels file to lay out what the prices were for the 4 independent variables and the labels for the dependent variables. And I've already done that ahead of time. But I'm opening up the data file. And we have an array of tabs here, and it just goes kind of in the order that you would do, starting from looking at your data files and defining your variables, all the way through running counting analysis, specifying logit models or hierarchical Bayesian models, estimating those models, managing your utility runs, and then conducting market simulations. And in so many ways, these steps feel similar to what you already are used to doing with CBC. And much of the theory behind the logit runs and the counting analysis just flows right from what you've learned with CBC. So you already have a leg up if you're familiar with the CBC software. We picked, of course, the Hawaii 2 data set in this particular folder. And I go to the Variables tab, and it says, well, I read in that CSV data set, I found the column labels, but I don't know whether they're independent or dependent variables. So I'm going to need to pick whether it's independent or dependent variables. And you can multiple select, and you can right-click, or you can use the fly-out menus here. And I'm going to say that these last 4 variables are the dependent variables. Now, right now, if I look at any of these variables, it tries to interpret the categories. It knows that there's 4 categories of these, but it has no labels on anything. And I've already prepared, you can edit, you could type and edit the labels here manually, but it's a lot easier to just create a labels file ahead of time, and the documentation describes how to do that in Excel. It only takes about 15 minutes to set up a labels file and import your labels, maybe even just 5 minutes on a simple study like this where I only have 8 variables. But if I've set up that labels file, I can just click this import button, and I can browse to and double-click my labels file, and just click that I want to import them. And now it's imported my labels. So for Lahaina shopping trip, the price for that ranged from $85 to $130, all the way through, the snorkeling trip price. The snorkeling trip price ranged from $80 to $120. Another thing I need to do is to get this thing going is to, for each of my choices, my dependent variables, if there's an on and an off state, if it's like a binary on or off, it makes it easier to do the counting analysis if we say which is the off state. And so for each of these, I'm going to say that the not chosen state is the off state. And that way, when it runs the counting analysis, it doesn't report the counting probabilities both for the on-state and for the off-state, which need to sum to 100%, and they're just complementary, so it's just a waste of time, and you get double the output to have to interpret if you don't do this. So I like to say that my my not chosen states are my off states and my variables, so that my counting analysis reports only report the probabilities for the on state, for the true states, because the off state is just complementary and not it's redundant information. You can go to filters and weighting to be able to specify respondent weights or to be able to choose which tasks to include in the analysis. Many people will discard the tasks, the first two tasks as warm-up tasks. Just for fun, we'll include all tasks today, but you can choose what tasks to include and how to weight your respondents. The next thing you do is you run counts. You can run the basic counting report is just to tabulate the frequency for all variables. And that will just do a tabulation in an kind of an output here that looks a lot like kind of an Excel report. But it will, for each of our independent variables and our dependent variables, will just report how frequently it found each of these values in the data set. And it was an experimental design, of course, that was nearly balanced. And so each of the occurrences of the prices of these independent variables is about balanced and nearly equal. But the important thing that we get down to is how often did people pick stuff? 29% of the time people picked the Lahaina shopping trip. The whale watching trip was picked 30% of the time. The surfing trip was most popular, nearly picked 40% of the time, and the snorkeling trip was picked 35% of the time. These values summed to more than 100% because respondents could it was a multi-select type of exercise. So people picked, on average, more than one item because the probability summed to more than 100%. But what we're really interested in is how changing the prices, like changing the prices for Lahaina shopping trip, affect the likelihood that people would pick the Lahaina shopping trip. On average, people would pick the Lahaina shopping trip 29% of the time. But depending upon the price of the Lahaina shopping trip, we could see that it could differ. So I'm going to pick the next type of counting report, which is the effect of independent variables on the dependent variables. And I'm going to run it, and I'm going to go to the tab that involves the Lahaina shopping trip. The Lahaina shopping trip was picked on average 29% of the time, but as we varied its price from $85 up to $130, the likelihood went down. If it's only $85, people will pick Lahaina shopping trip 49% of the time on the menu. So you guys don't lose track of what we're talking about. Again, we're talking about what's the likelihood of people picking this box depending on this price change, okay? And that's what we're seeing here. And it's definitely a strong downsloping demand curve. As the price goes up, the likelihood of picking Lahaina goes down. The chi-square is on the frequencies behind these proportions is highly significant with a p-value of 0. Interestingly enough, you can also see that the Lahaina shopping trip prices can also affect the whale choice. Let's go over to whale choice. If you go over to the likelihood of picking whale, the whale shopping or the whale watching excursion, on average it's 30%. But as Lahaina's price changes, let me go back to the menu again. As this price changes for the Lahaina shopping trip, the likelihood of picking whale will significantly change because that's a significant cross effect. Shopping in Lahaina and whale watching happen to be kind of close substitutes. And so you can see that as Lahaina price goes up, the likelihood of picking the whale trip goes up because people will switch out of the Lahaina shopping tour and go whale watching. And that also has a statistically significant p-value. So the summary tab on the counting analysis shows you for dependent variable Lahaina choice, what are the significant variables? Lahaina price and whale watching price, we already saw, had statistically significant with p-values near 0. The likelihood that that could occur by chance is near 0. Those appear to be significant effects. But the surf price and the snorkeling price really don't have any statistically significant effect on Lahaina. So you can use the counting report also for whale choice and for surfing choice and for snorkel choice to see which variables are statistically significant. And once we've done that, we can kind of carry that report with us in a pop-up dialog. And I'm going to do that. I'm going to just carry it along with me in a pop-up dialog. But now I'm going to go over and specify my models. I'm going to specify, and there's different ways to specify models. The simplest way to do it is with just 4 binary logit choices. But there's more sophisticated combinatorial ways to code the dependent variables to have a more combinatorially insightful model specification. But the default that tends to work quite well for many types of menu-based choice modeling is a series of independent binary choices. So we're going to create some binary logit models. We're going to start out with modeling Lahaina choice. This is one of my 4 dependent variables. And when you pop it open, you say, hey, do I want to run, what kind of model do I want? What independent variables do I want to use to predict choice of Lahaina, of the Lahaina shopping tour? Well, I know that the Lahaina price, the own effect was statistically significant, and I know that the cross effect of whale price, remember I saw that in the counting report here. If I look back at it, I find that when I'm talking about the dependent variable Lahaina choice, I know that the Lahaina price and the whale price were statistically significant. So I'm going to include these in the model. And I could do a part worth estimation versus a linear estimation, but to keep things simple here in this example, I'm just going to say that they're linear for now. Also, I want to predict my whale watching choice. And the independent variables that were statistically significant there were, of course, the own effect of whale price affects the likelihood that people are going to pick the whale trip. And the cross effect for the Lahaina shopping trip, it appeared to be a statistically significant cross effect as the counting report showed over here. And I remember, because I've done this data set before, that when I do surf, I need the surf price to predict it, and I need the cross effect of snorkeling, because the 2 water trips, surfing or snorkeling, also are substitutes for one for another, and they also have a statistically significant cross effect or substitution effect. That's the way that I built this particular study, because I built the data and I constructed the data for this example. Snorkel is predicted by, of course, the snorkeling price affects whether people are going to snorkel or not, and as a significant cross effect, the surf price. So once I've specified my models, I can actually, if I want to make sure, I don't want this to be a black box. I can preview my models. I can preview the design matrix, and it will show me, for those of you who know about coding design matrices, this way you don't get lost in the software. It will show you for respondent number 1 and task number 1 how it is dummy coded and linearly coded, zero-centered coded, these effects. And this is all described in the manual, but what I love about the software is we've kept it from becoming a black box. We know that you guys are sophisticated researchers. We know that you guys know how to specify a design matrices and code your data, but we know that you don't want to have to do it yourself. We know that you want to model a piece of software that will do it for you, but you want to be able to look at your design matrices, export your design matrices, and so you can do this preview design matrix. For example, if you want to change snorkeling price to be a part worth dummy coded, now you can preview to your design matrix, and you can see that now it's coded as 1s and 0s, dummy coded, rather than with a linear term like I previously had it. So it allows you to toggle back and forth between different types of model specifications, but it handles all the work for you in terms of the design coding, and you can keep track of what's going on so you don't get lost by always previewing the design matrix. Well, once we've set up our models, all we have to do is go over to the Estimate Models tabs, and we can, by clicking these links, I can estimate my 4 aggregate logit, binary logit models, or the HB versions of those binary logit models by just clicking the estimate. The cool thing is that when you click these, you can run them all simultaneously, and it will do them on multiple cores of your processor. So if you have an 8-core processor, you can simultaneously run 8 hierarchical Bayes runs at the same time, going almost nearly 8 times as fast as you could if you were doing it manually using CBCHB software, which won't support multiple core processing. So if I want to estimate all the logit models, I can just click estimate them all. It queues them up, it runs them all, and I can just review one by one the results. The Lahaina dependent variable, oops, let me get, there we go, resize it.
Hey, Brian,
the run includes 250 respondents. Yes.
We're at 9:50 your time, so about 9 minutes until we're technically done. And we can go longer.
Very good.
Should people want to continue to participate?
Okay, let's go ahead and show what more you can do. We're going to go back to the webinar and launch where we left off. And I'm going to show an example that that was the Lahaina shopping trip, and the Maui options on a cruise ship. But now we're going to turn to something slightly different, because you can do all sorts of things with this tool, whether it's menu-based choice or discrete choice. It's a very good full tool for all sorts of things. For example, at the last Sawtooth Software Conference, I showed a perceptual map, or it's really a heat map example as an extension of CBC simulators. Typically, you're used to a simulator in Excel where, for example, for travel destinations, and here we have 1, 2, 3, 4, 5, 6, 7 particular travel packages consisting of a destination, the number of nights, the number of hotels, whether it's a business or boutique or resort, the car rental, the price per person. And typically when you have a simulator like this, you use drop-down boxes and it will show you the shares of choice, the shares of preference. You're used to having these types of simulators. But what you can do using menu-based choice software, and a few tricks that I'll show you, is you can append to this a heat map of perceptual agreements statements like this. Now, in addition to seeing the shares of preference, you can see the percent of people that would associate this particular product as being fun or creating lifetime memories, etc. I'm going to go over and actually launch this in Excel. It's just an Excel simulator. And you can see that the Las Vegas trip right now, 60% of these people think it would be fun. And 30% of these people think it would create lifetime memories, in addition to, of course, 17% of them having chosen it. So when you go over here and you say, well, let's not make this Las Vegas hotel be a business resort, a business hotel. Let's make it be a resort hotel. When I change that, you will see that not only did the shares of preference change, but the perceptual agreement predictions change. Previously, people thought this Las Vegas trip would be 60% fun, and now 66% of the respondents would be projected to agree that it's fun. So this creates more insights for your clients. Not only can they see the shares of preference, but they know why people think that they prefer it. Why do people like this Las Vegas trip? Well, they like it because it's fun. Why do only 4% of the people want to go to this Washington, D.C. trip at a business hotel costing $650 per person for this particular travel package? Well, that's because it's not as fun. They do perceive that it educates them more, this Washington, D.C. trip, but it's just not as fun. So this is a neat way to add an extension, a heat map extension, to give more insights into your conjoint analysis simulators that you can deliver to your clients. How did I do this trick? Well, I did it by appending to the bottom of a regular CBC task some perceptual check as many apply agreement questions. So we asked people, well, here are 3 packages, which is the best and the worst, a standard CBC, but then we said, hey, for each of these packages, Would it create memories to last a lifetime? Would it be too expensive? Would it have good weather? And we randomized the presentation of these items as they came in and out of these tasks. Yes, it's longer for respondents to do it. It takes about double the time, but you get a lot more insights, and you get this cool heat map extension of your regular CBC simulators. More details regarding how to do this heat map extension of CBC simulators for perceptions is going to happen in a webinar that we present on December 9th. And you can also read more details about how to do that on a technical paper that we have available up at our website. So with that, I'll turn it over to Megan.
Great. So hopefully everybody's enjoyed all of the information that we've given today. One of the questions was if people will have access to the PowerPoint. They will. We will be sending the PowerPoint along with some of those references that Brian had mentioned to some of the white papers, as well as some example.ssi files. But we did want to mention, since this is a suite holder exclusive webinar, many of you with the standard suite actually don't have the MBC software yet. So it's actually pretty simple to upgrade to the premium license, which offers the MBC software and actually also offers the CCS desktop client simulators as well. So if you upgrade to the premium suite, it'll cost you about $3,000 more for one user. And then we also offer our Premium Suite Plus, which has the 5 hours of free consulting and 15% off workshops and conferences for $4,000 more. So you can see that information on our products and pricing page on our website. You can email me and we can talk about your current license setup, but you can see that there are savings as you are a suite holder, because our single user component license runs at about $6,000 per year. One of the nice things about the Premium Suite Plus is that 15% off workshops and conferences, because we do a 2-day MBC training, which oddly enough is how I learned how to do MBC. Our next one is going to be in Rome, and we are looking to see how that will be in April. We're looking to see what the interest is in a 2-day workshop as well, to maybe have one before April. So as you receive my emails with the recordings and the links to the papers and the file, feel free to shoot me an email back about your interest in the actual workshop itself, or if you would like any more information on how to start becoming the niche MBC user that Brian has hopefully taught you how to be today. So any other questions, feel free to type them into the questions box. Brian, did you have any other comments about how somebody could grow in their skills with MBC aside from the workshop and reading the MBC documentation?
Well, those are the two good starting points. The best thing to do is to create a simple example for yourself, such as this Maui excursion, where you think up a very simple menu and you create some data in Excel, and you can get a trial version of the software, take a look at it, and see what you think. Follow the documentation. The best thing is really applying it and trying it. There are some interesting additional papers, like the paper from David Bakken and the paper from Chris Moore, papers that I've presented at the Sawtooth Software Conference. So there's 3 or 4 papers that have been written up that you could also read if you like reading papers. But if you're a doer, you probably just want to jump in and get a trial version of the software and see and start constructing some example data sets before you actually try to do it in practice.
Great, thanks, Brian. And that looks like that's all our questions, and we're about a minute until our time's up. So again, thanks everybody for coming, and hopefully you are enjoying these exclusive suite holder webinars, and we look forward to hearing your feedback in the survey link that you'll be receiving shortly. So thank you so much.